So make sure you have the paper. We're going to do today, we're going to do 4.8. It's inequalities and systems. Okay, to solve an inequality that is in factored form, solve an inequality that is in factored form, remember, factored means that it looks like this. We've got a list of factors. To solve an inequality that is in factored form, we will set factors equal to 0. I guess we should put and solve. We're going to make a number line. And then we'll get our answer. Even if you feel a little bit lost or a little shaky on everything that we've done so far, you can still learn what we're doing today. It's been a minute, but when we solved inequalities, we talked about less than and greater. And so one way that we need to, or one thing that we need to associate with less than is less than and. Greater or. Y'all remember when we did that day? Maybe you have no memory of what it is we learned that day, but I was saying that over and over again. Less than and greater or. Y'all remember that? It's coming back. So we're going to do the same thing. Less than and greater or. So this is when we're solving. So when we're solving these, looking at the inequality symbol, we're going to use and or. So when we look at this symbol, is that less than or greater? Less than. So let's go ahead and give ourselves a reminder that less than symbol looks like that, greater symbol looks like that. And again, it doesn't matter if it's also got the equal to. They're both the same. So that's what less than looks like, and that's what greater than looks like. Less than and greater or. So when I look at A is less than and. When I look at B, what is that? What symbol is that? Greater. So it's or. The reason why I stress this to you is because it tells us how the answers are going to be. So and means that it's together. Our answer is together. And or means I'm going to have this or this. So it's how we're going to have our answers. So before I even start working these problems, I know what my answer needs to look like for an inequality. When it's an and inequality, I put an X in the middle. And I'm always going to have inequality symbols facing to the left. And only if it has the symbol underneath, if it has the and, I'm also going to add the and. When it's not there, you don't put it. So less than and. When it's greater or, that means I'm going to have this or this. So I'm going to have or this or this. And to set myself up, I'm going to have X less than something and X greater than something. And you would put the line underneath the equal symbol. If it was equals, you'd put it there. So this is the way you'll set it up every single time. All we have to do is figure out what the numbers are. I need to figure out what number goes on this side, what number goes on this side. What number goes here, what number goes here. So to figure that out, we have the factors. So if it's in factored form, it's super easy. I'm gonna set each factor equal to 0 and solve. That's our first step. Set each factor equal to 0. So I get x plus 3 equals 0, x minus 1 equals 0. These are both one-step equations. They're super easy. So x plus 3 equals 0. I need to subtract 3. So x is equal to negative 3. X minus 1 equals 0. I need to add 1. So x is equal to 1. Any questions so far on just the solving part? Could we have done that in our head? Yeah, we probably could have. So for these problems, if you do some of them in your head, like I understand, some of these are pretty easy. If you struggle with that, then don't try and do it in your head. Try and write it out. Okay, we did the first part. Set the factors equal to 0 and solve. Okay, now we need a number line. So I'm gonna, and it doesn't have to be something super fancy. It's just a line, and we're gonna put the two values on there. I've got negative 3 and 1. You just have to put them in order. Sometimes they're, when you solve, like you've got to write them in there like this. Just, it's coincidence that these happen to already be in order when you solve it. When we have a quadratic graph, what is that shape? It's a U, okay? So what we just did was we figured out the two spots that it would cross the x-axis. That is the solution. We learned that back the very beginning. Our first day of quadratics was, where does graph cross the x-axis? Those are my solutions. And it's going to be a happy face as long as it's positive. If I look in front of my parentheses, there's not a negative, right? Therefore, it's positive. No negative in front of these parentheses, therefore it is positive. So every time we've got that positive graph, it's going to go through these 2 points. That's what my graph would look like if I actually graphed it. So to solve this problem, what it's actually asking you is this. It says, when is that stuff, if it was graphed, when is it less than 0, less than or equal to? So this is the line of 0. And when you're bigger than 0, you're up here. When you're less than 0, you're down here. So this is asking, when is your graph below the x-axis? When is your graph below the x-axis? So the graph is below the x-axis right here, right? Anybody confused on that? That's where your graph is below the x-axis. So when we answer this problem, we're answering to say, oh, my graph is below the x-axis when x is between negative 3 and 1. Y'all agree? That's when the graph is below, between these two numbers. So you go take those two numbers and you write them in your inequality, negative 3 and 1. That's it. The next question, we're going to solve it the same way. You split these, we'll set them equal to 0. So I get x minus 5 equals 0 and x plus 5 equals 0. So I get x is equal to 5 and x is equal to negative 5. Do y'all agree? We could have done those in our head. Now we make a number line. So on my number line, I only have two numbers. I have to put negative 5 on the left and 5 on the right. Is this a positive graph? And here's a hint. All the ones that I have you solve algebraically, they're gonna be positive graphs. Okay, so these are probably always positive graphs. The only reason it wouldn't be is if there's a random negative sign out in the front. So if I had a positive graph, it would look like that. The question is asking, when is the graph above 0 or above this x-axis? Well, we know that below is going to be the part that's connected. It's not there because that's below the x-axis. So above the x-axis is here and it continues on, and it's here and it continues on. Do y'all agree? That's when your graph is above the x-axis. So your answer is representing that space in this space. That's why it's an or answer. It's here or here. So when we answer that, you will always put, if you set it up to where you write less than first, it's always the smaller number goes with the first blank and the bigger number goes with the second blank. So my answer to when is your graph above the x-axis, which is what this is asking. Oh, it's when x's are below -5 or when x's are bigger than 5.
And you use and or depending if the sign in the equation's less than
You can also pick a number and plug it in and check to see if it's true. So like this first one, a number between 1 and -3. There's a bunch of numbers. You could pick 0 if you wanted to. If you picked 0 and you plugged it in, then if you plug it into the equation, it will make the equation true. That's one way you can test and see if you wrote it correctly. But that is it. The next two problems, we're going to do the exact same thing. We just have one extra step. So this says to solve an inequality that isn't in factored form. Well, we just solved them and they were in factored form. So what do you think we need to do with something that isn't factored? Factor it. So we have to first factor. Then we're going to set equal to 0 and solve. And then we'll do a number line. All of the problems that I give you and I expect you to factor, when I expect you to factor these, they are easy, fast factoring. They're all meant to be easy because I'm not really testing on these problems to see if you know how to factor. I want to see if you know how to find the solution. So the first thing that I'm going to do is first decide what the symbols tell me. For this one, that is a greater symbol, so that's an or. And when I set up an or, I have x less than something or x greater than something. Again, I didn't put the equal to sign because this one doesn't have an equal to. For B, that's a less than, which is an and. And is together. You put them together. So you will always start out with the x in the middle and the inequality symbols face that way. This one has the equal to sign, so I'm going to go put equal to signs underneath those. So now for both of them, all we have to do is factor it so we can figure out what numbers go there. For A, it's been a while since we factored, so I'll go slow. What we're doing is technically A times C, so 1 times -4, or we can just look for factors of 4. There's a short list, factors of 4, 1 and 4, 2 and 2. We're looking for the pair of them that we could put together to make 3. 1 and 4. So when I set this up, I'm ready to make parentheses. I have x, and remember, we're going to solve it by setting it equal to 0. And I put 1 and 4 in the parentheses. When I put them in parentheses, now I have to figure out what symbol goes here. Is it going to be plus or minus? I look at the middle term. The middle term is negative, so it tells me the bigger number will be negative. So 4 is negative. If 4 is negative, would I add or subtract 1 to make it -3? I would have to add 1. I don't know why I put a 1 there. Oops. I made it 11. Okay, now we're at the same step that we were on for A and B. All we have to do is split it, set them both equal to 0. So I get x is equal to -1 and x is equal to +4. Do y'all agree? I can make my number line. I'm going to have -1 on the left and 4 on the right. For this one, it's a lot easier to see. It's in standard form, but that's okay. Is this a positive or a negative graph? You look at the leading term is positive. So the shape is a U. It's going to go through both of these points. It's asking when it's greater. So my graph is greater on these two sides. Does anybody not see why it's on the sides? Okie dokie. So we know what we put in these two blanks now. It's -1 and 4. For B, I have to factor it. To factor it, I need factors of 12. We've got 1 and 12, 2 and 6, 3 and 4. Can you think of any others? I think that's it. So when I make my factors, I'm going to have an x and an x. Which pair can I put together to make 8? 2 and 6 will work. So I put a 2 and I put a 6 in here. Doesn't matter which one you put it in. I will look at my middle term. My middle term is positive. So the bigger number needs to be positive. So 6 needs to be positive. If I have 6, would I add or subtract 2 to make 8? Add. And I know that I've said this before, that if your problem doesn't have any negatives in it, your answers aren't going to have any negatives either. So if I set each one of these equal to 0, I get x is equal to what and x is equal to what? -2, -2 and -6. If I go put those on a number line, which one is smaller? The -6 is further away from 0. So -6 and -2. So you do have to be mindful. They aren't always that the left one goes on the left. Is this a positive graph or a negative graph? Positive. So my graph would sketch on like that. And when I look at it, it's saying less than. So less than and together, it's always the spot where they're together. It's not the spot where they're apart. So it's below 0 here. Do you agree? So that's what we put for our answer. We put the smaller number on the left, -6, and the bigger number on the right, -2. Are you good so far? Good. Moving on. Now, what if I gave you graphs? Could you look at a graph and tell me when you are less than or equal to 0, or greater than 0, or greater than or equal to 0? Sure, you can. So we are going to look, this one, the first one. So this basically is like at the number line part. We're already at the number line. So when we're already at the number line, the only part that we have to really look for at the equation, because we don't need the equation, we did all of the factoring and stuff to be able to get our answer. The only thing you care about is what it's asking you to look for. So the equation itself doesn't matter at this point. Here, it's a less than. Less than is and. We're also looking for when are you less than? You're less than here. I'm going to actually erase this part. I'm going to erase the less than and, because only if I give you a graph, sometimes it can be tricky. You're still looking for only that. When are you less than 0? When's your graph below 0? It's here. For this one, it's asking when is your graph above 0? So above 0 is actually in the middle, right? It's right here. That's when you're above 0. So I'm going to highlight that part real quick. Let's look at the last one. When are you above 0? That would be on the ends, right? That's when your graph is above 0, is on the ends. I want to talk about for a second, if we look here, this graph is a positive graph and it's less than and. This one is also a positive graph. It's greater or. This one is a greater graph, so it should be on the ends, right? Does anybody know why it's actually not? Because it's negative. Do you remember what you have to do when you divide or multiply by a negative? You flip the sign. So that's the reason why when you look at this one, that even though it says greater or, that it ends up being an and graph because it's negative. So that's the only time that they're a little different. But if all you do is look at the graph, it should tell you what kind of answer you get. The ones that have the answers on the end are always an or answer. So the ones with the answer that's in the middle, that's between, you will always set up with your answer like that. This one we have to put equals to. This one is in the middle, so you set it up like that. You don't have to put equals to because there isn't one in the problem. And the last one is an or graph because it's on the ends. So you set it up with less than first or greater than, and you put the symbols, you put the equal to underneath because it's in the problem. So now all we have to do is go look for those values. Where does it cross? So I'm going to write the answers up on the board. You look at your graphs and you write it down on your paper. Let's just make sure that we get the same answers.
So it is just the points in between that.
Mm-hmm. Should all get the same things? Okay, the front side. Are we okay with that? We good with the front side? Any questions? When you start working on the homework, you can ask me questions. All right, flipping it over. The first question on the back is oh, I didn't even answer that part. It says to solve an inequality that is graphed. I was going to give y'all directions. You literally just look. You look. You read it like a number line. Read like a number line. All the algebra is already done for you. And it's already graphed. You just look. Read it like a number line. On to the back, there's a question. Read it and answer it. This problem says a meteorologist creates a parabola to predict the temperature tomorrow. X is the number of hours after midnight and Y is the temperature. So reading the scale of this graph, it says that along the bottom, we've got hours after midnight. And vertically, we've got the temperature. The question says, when is the temperature below 0 degrees? Shade your graph where that is. Where is that? Is this going to be an and or an or? And that's when my graph is below 0, right? Okay, well, let's look at those X values because it's the answer is always X values. So it says, when is the temperature below 0? So what's the first X value? What's the next X value? 24. So the problem's written in words. We could answer in words. So when is it below 0? Between 4 and 24 hours after midnight. You could have also said between 4 and midnight. That works too. 24 hours after midnight is the next midnight. Again, the word problems for all of this unit are easy. All right, the last thing that we're going to talk about is systems. So the solution to a system is where the two graphs, anybody know this? Because we've already done systems before. Y'all even made posters. They're over there. They're pink and white. What do we look for if we're looking for a system of equations? What are we looking for? It's where they cross. So if it's two lines, we're just looking for that point of intersection. Well, we're doing quadratics, so we're looking at a quadratic and a line. We're still looking for where the two graphs cross, or in math, it's intersect. They can also just touch or touch. So they either cross or intersect, but they can also just touch. If they touch, that's also considered an intersection. For a system with a line and a parabola, you can have 3 types of solutions. So as I draw these, I'm just going to draw positive parabolas, but same goes for if they're negative. So I'm just going to draw 3 positive parabolas, and I'm leaving myself a little bit of room at the bottom so I can write stuff down. Again, same goes if these are negative. I'm just showing you the 3 types of situation. The first type of situation that can happen is that you have a line. This could be a positive line or a negative line. It really doesn't matter. You have a line and it goes like that. Another situation that can happen is that you have a line. It could be negative, it could be positive, doesn't matter. But you have a line. Mine's kind of not very straight, but it goes like that. Another thing that can happen, what do you think the next one is? Not touching. So to not touch, it would have to be something like that. If it was like straight up, then it at some point would go through the graph. So in words, we need to know that the first situation, we have two solutions. The second one, we have one solution. And the last one, there is no solution. And we have a symbol for that. It looks like that. Half the problems I give them to you and they're already graphed. Half the problems you have to graph them. So the ones that are already graphed, let's get all of those correct. It says use the graph to solve, write the solution as a coordinate. Remember, a coordinate is always x, comma, y. Being able to identify a coordinate is extremely important. This is why I make you do the mystery graphs. When we look at A, how many solutions will I have? 2. What about B? C? And D? All right. I'm going to write these up on the board. Don't look up until you've answered these problems on your paper. I want to make sure that you can write a coordinate. So don't look up until you answer them. 2 points, 2 answers. Did anybody get something different and you're brave enough to tell me what you did? Anybody mess up on one of them? What'd you do? Oh, so you can't see them. Anybody else mess up on one of them? Anybody confused on one of them? Do you agree with my answers? Okay. Do we think this is easy? Good. The next 3 are just as easy, but we have to put the graphs on there. So I'm going to go a little fast because we just did a quiz over graphing these. We're going to get a quadratic and we're going to get a line. So to graph a quadratic, I need 2 things. I need a vertex and I need to know A. For the very first one, A is equal to what? What's A on the first one? 1. And then what is my vertex? -3, -4. So I'm going to go plot that. I have to go to -3, -4. I put a point. When A is 1, I go over 1. 1 squared is 1. Oh, am I positive? I'm going to go up, right? When I go over 2, 2 squared is 4. So I go up 4. When I go over 3, 3 squared is 9. So I would go up 9. I'll use symmetry to sketch this on there. I got all my points. I'm going to work really hard to try and make this curvy. My second graph. It is a line. To make the equation or to sketch on a line, you have to first do your y-intercept, and then second, you do whatever the slope is. So my y-intercept is 1. So I go up to 1 and I put a point. The slope is whatever is in front of the x. What's in front of the x? 1. That means you go up 1 over 1 and you continue. And you can use the pattern to figure out that if you go left, I have to go down like this. So I got points on there. I'm going to connect the dots. How many solutions do I have? 2. I have that one and I have that one. I can list them as coordinates. I got -4, -3, and -1, 0. Do you agree? Ella agrees. What about anybody else? Okay, good. The next equations for us to graph. Ooh, that one's negative. So I'm going to have to make sure anytime I have negative, I kind of need to remind myself I'm going to face down. A is what? It's the stuff in front of parentheses. -3. What's my vertex? 5, 5. All right, I'm going to go put a point at 5, 5. Over 5, up 5. And I gave you that hint last time that a lot of times when I have you move up, it's because your graph is going to face down. So I'm going to go over 1, but instead of going down 1, I have to do 1 times 3. So I have to go down 3. If I go over 2, 2 squared is 4, but it's 4 times 3. 4 times 3 is 12. That's off of my graph. So I only have 2 points, but I'm going to still try my best to make it look curvy. It'll be something like that. It's hard to draw them when they're really narrow. For my second graph, what's another name for f of x? I think y. So if f of x is y, that's the same thing as y is equal to 2. Do you see an x in that equation? No. So it's just a y equals line. That means it cuts through the y-axis at that value. So I go find 2. 2 is right here. It just means it's a horizontal line that cuts through the y-axis. How many solutions do I have? 2. So I got 4, 2, and 6, 2. Is that what y'all got? Good, 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 good. We got one more that we're going to graph together. Ooh, this is another negative graph. What is A for this one? -1. So we're going to do those same movements, 1 and 4 and 9. It's just facing down. What's my vertex? 1, 3. So I'm going to go plot that over 1 and then up 3. So I'm going to go over 1, down 1, over 2, and then down 4, over 3, and then down 9. I'm going to use symmetry to make the other half of my graph. And try to make it look curvy. To sketch on my graph, I still have a slope and a y-intercept. I have to do the y-intercept first and then the slope second. So the y-intercept is at 6, so I go put a point at 6. The slope tells me it's negative, so I'm going to go down. It says down 2 And then I'm gonna go right 3. So I go down 2, 1, 2, and then to the right 3, 1, 2, 3, and I put a point. And I'll continue doing that. Down 2, and then to the right 3. And then I will sketch on my line. Where are they gonna touch or intersect? Never. There is no solution. They do not cross. That is all we have today, friends.